Alright, so we're given, this is a volume by splicing problem. So we're given y equals x squared plus 1, and then we're given y equals 9 minus x squared, so those are two functions that we're dealing with. And they want us to rotate around y equals negative 1. So first, you want to make sure you sketch a graph of the two functions and the line that they want you to rotate about, just so you can get an idea and kind of visualize what kind of structure these functions or what this volume is going to look like. So first, I drew the blue line, which represents the function x squared plus 1. And then I drew the red line, which represents the function 9 minus x squared, because it shifted up 9 and it's reversed, so you can see where these two functions came from. And then I drew my rotation line, which is y equals negative 1. It's just the it's the axis of rotation where they want me to rotate this kind of picture. That's how it's going to generate this volume. So I want to make my delta x perpendicular to the rotation line, so y equals negative 1. So since this is in this direction, so I want my delta x to be in terms of x, and that's how my two functions are in respect to, they're given in terms of x. So right now I want to find these two endpoints where these two functions intersect with each other, because that's how I know where to take this area and then apply the theorem of volume for a washer, and that's how I'm going to get my full volume for this three-dimensional shape. So here I just set the two equations equal to each other, the two functions equal to each other. So x squared plus 1 equals 9 minus x squared. So you add the x squared to the other side, subtract 1 on this side. So that's where you get the 2x minus, or 2 x squared equals 8, and then I just divided by 2. So then I got x squared equals 4. So to get rid of that, I just square rooted both sides, and whenever you square root, you have to make it positive and negative. And then the square root of 4 is obviously 2. So then I get positive and negative 2. And that's what you can see whenever you draw the two functions. You can see where x equals 2 intersects for both functions. And the same case for negative 2, x equals negative 2. So I found my two endpoints with respect to x. So right now you can see by the theorem of volume for a washer, the volume equals, and then we have these two bounds, a and b, so we already found our two bounds, which a equals negative 2, right? And then b equals 2. And then pi, and then f, or your first function squared, minus your second function squared, and then all respect to x. And then you take the integral of that. Alright, so now that we have our bounds and we have our two functions, we're not done yet, because this is the axis of rotation is y minus 1. It's not over the x-axis or just simply the y-axis. So we have to find this inner part, because these are two radii. So the lower bound that's closest to the axis of rotation is going to be considered your inner radius. And then your outer function that's furthest away from your axis of rotation is going to be considered your outer radius. So from here I can tell that my red function, which represents 9 minus x squared, is going to be my outer function, my outer radius. And then I can tell here that my blue function, which represents x squared minus, or plus 1, sorry, will be my inner function. So before I do that, I can't just make my radius equal these two functions because they're off they're a certain distance away from y equals -1. So I have to figure out that distance and compensate by taking that function. So for each case, for the outer and inner radius, I have to figure out its radius from the axis of rotation. So that's why I did, for the outer function, for the outer radius, I did 9 minus x squared. Then you just subtract the distance from the radius, or the axis of rotation. So that's why I subtracted -1. And then I got 10 minus x squared. And then I just apply the same kind of same thing for the inner radius. So I took the function x squared plus 1, then I just subtracted that by -1. So you're just adding 1 to each one. And then that's where I got x squared plus 2. So now this is my outer radius, and then this is my inner radius. So now I plug these in the theorem volume of a volume of a washer. So first you take your outer function and you subtract it by your inner function. So in this case the outer is f of x, and then in this case x squared plus 2, which is inner, is going to be g of x. So then you just square root this inner function in the parentheses, and then you do the same for the inner radius. So then here I got x to the 4th subtracted by 20 times x squared plus 100. And that's my outer function, squared. And then I took my inner function and I squared it, and I got x to the 4th plus 4 times x squared, and then plus 4. And here I can tell that these x to the 4ths would cancel out, and then I have -20x squared subtracted by 4x squared, and that's where I got -24x squared. And then here I get 100 subtracted by 4, which is 96. So this is kind of my math from in here. I subtracted it, simplified it, and then you continue on to taking the integral. So here you have your two bounds, -2 to 2, +2. Your lower bound is -2, which is at this point, and then you're moving from left to right, taking each d of x, and then your upper bound you stop at x equals 2. And then you just keep on going and you take the integral. So pi is going to be here. You can take it on the outside because it's going to be a constant. So you're left with taking the integral of -24x squared plus 96 dx. So if you take the integral of this, you get -24, and then you add 1 to the exponent and then divide it by that new number, which is going to be 3 in our case. So it's going to be x3, and then -24 divided by 3 is just -8. So you're left with -8x cubed. And then add 96x, because if you add with just a number right here, you just add on an x. And then you're taking it from the original bounds, which is x equals -2, which is this, our endpoint, our leftmost endpoint, and then we're taking it to our upper bound, which is x equals 2. So that's where these numbers end. And now from this point, all you have to do is plug it in, do the math, and then you figure out the answer. So you plug in the uppermost bound into this function. So it's going to be pi times -8 2 to the 3rd plus 96 times 2. So -8 2 to the 3rd is just -64. And then 96 times 2 is just 192. And then you subtract by the lower bound by plugging in -2 into the x, wherever an x is. So it's going to be -8 times negative 2 to the third, which is still going to stay negative, so a negative and a negative become positive. So we still have the same magnitude, it's just going to be positive, so 64. And then we have 96 times negative 2, which just comes out to negative 192. So right here we're taking negative 64 and adding it to 192, which is 128. And we're multiplying it by pi. And then here we're taking 64 and subtracting it by 192, which comes out to negative 128 times pi. And a negative times a negative is just addition. So it would be 128 times pi plus 128 times pi, which comes out to the answer of 256 pi.